the point is, as I told you before in the morning, that until we conceive the water molecules, but not this speech is not valid only for the water molecules. Igor Yerman this morning asked, about the homeopathic preparation, also about the solution with ethanol, water. This perspective on condensed matter can be applied to any kind of substance. Of course, each kind of substance will have his or its own dynamics that must be, of course, unraveled and detailed. But the conception, at least for polar molecules like ethanol and water, this conception is pretty general. So until we imagine water like this, we have difficulties to imagine long-lasting dynamics, some stuff like memories or whatever. But it's not necessary to go to so exotic properties like the one that we can retrieve in potentized remedies, but it's already sufficient to go to very trivial and daily phenomenon like the salt solution, or how water change the density with temperature, that we notice. We are able to notice that this picture cannot work. Okay, cannot work. So the point is to pass from a sticks and balls vision to a field view. This is something that I've been continuing having knows to say, because it's the crucial point when, above all, in the world of chemical physics, and above all in spectroscopy, because in spectroscopy people imagine this kind of system to rotate, to stretch, to symmetrically, asymmetrically, or to bend, and they say this is this motion, this other motion, this other motion, the degrees of freedom. I will suggest my own thought about this on this point. That I think that all this motion that we are yes, that we think are attributable to single molecules actually are attributable to something different that I will tell you later. Of course, just to make a short, framing of the problem. No, when you speak to a physicist and you tell him that water is coherent, the first reaction is a very fat laugh about the fact that coherence is always is only possible, at very low temperatures, or if you provide an energy that can make the so-called population inversion, and so a pump. But the problem, this is true for firstly, if we speak about very, in the sense that if we neglect, okay, the coupling that the so represented, matter object like molecules, if you represent them as immersed in a classical vacuum that is just empty space, or just a quantum mechanics vacuum that is something that conceive the perturbation that the molecule, for instance, the molecule of water is subjected to, very tiny. That is true because we know, everybody knows the Lamb shift, that is the little difference that the electron on the hydrogen, the electron that is on the s orbitals of the hydrogen. Anybody knows that this level is a little different from the predicted Bohr model, by a factor that is 1 part per million. And this variation is attributable to the coupling with vacuum. What is this coupling with vacuum? The fact that vacuum is a continuous and unceasing teaming of excitations. Excitations that at this level are manifested as, let's say, electromagnetic excitations, let's say photons, even if I don't like this word so much, but because give a wrong idea of the vacuum, like something that is full of little balls scrambling here and there. But imagine like a sheet that is continually, or like the surface of the sea, that is never completely flat, that has something that is rippled, no? Rippled. Of course, if we consider these ripples for a single molecules, these are very little. So anybody says, yes, exists the coupling with the vacuum and water molecules, but it's very little. It's just 1 part per million. Yes, it's true. If we consider just a few body system, we will never be able to conceive that this perturbation, that I will explain a little better, how is it, could change the system, could change the ground state of the system, the connotations of the system. And they imagine, usually in the main frame of the condensed matter, that when you have an n-body system, so a lot of objects that should be provided, each one with a Lamb shift, let's say, quantity of energy, you should provide this energy by a pump. But they neglect what? They neglect some factors of the coupling. I just make short this part just to not bother you too much. They neglect some part of the coupling between the electromagnetic field coming from the vacuum excitations and the molecules. So in this approximated picture, it's not possible to contemplate the fact that when the molecules reach a certain density threshold, so they are many enough within a space region, they can enter a new state that is guaranteed and provoked right thanks to the vacuum fluctuation. Vacuum fluctuation, just to express a little better, what are they? As I told you, they are excitation, let's say the emerging of non-zero values of the electromagnetic field, but usually they are excitation that lasts a time that is the shorter as the energy is the higher. Of course, so the higher is the energy of this excitation, following the Heisenberg rule, the shorter is the time. And they are called virtual quanta, virtual photons, because they last just a glimpse of an eye, just to make a metaphor, no? Actually, this is true. This is true, but when the vacuum is just vacuum. But when vacuum is together with other elements like matter components, something different happens. And don't be frightened for the equation, because you are not asked to learn the equation, but it is just a representation to simplify and to sketch out the theme. Follow my word and my speech, because it's the main aspect that you need to take to understand the picture. The point, the simple point is this one. What is exactly the Lamb shift? What does imply that a water molecule in the space is subjected to some virtual quanta? Very shortly, this implies this point, that the electrons, the electrical charges, are excited lightly or very tiny, if we think of very little excitation, to another level, no? In the sense that the system absorb for a while, for an instant, this virtual photon. The electron charge is pushed up, shifted, is pushed up in energy. And of course, this unstable and higher energy level with respect to the previous is soon but during this process, what does happen? Happens that the motion of the charge, for instance, let's think about the electron on the hydrogen atom. That is the model from which this kind of studies started. The electron, the motion of the electron actually is an electrical current because it's a charge that is in movement. This electrical current actually is also an electromagnetic wave because it's a charge that moves very fast in an alternate way. So there is a coupling between the electrical current and the photon in a way that, if you remember the Faraday lens law, you produce a variation, no, of the field that opposes the motion of the charge. If you move a magnet inside a copper wire, you create a current, no, that creates a field that try to be opposite, no, to the field that provoked the current. And this is a very big fortune. It's our luck because otherwise you would have a system that would have the feedback, a positive feedback that is a divergence. No, if you move a magnet and you create the movement of a current in a wire through the movement of the magnet, you would generate a current that self-amplify. Of course, no, that self-amplifies, and this doesn't happen. So the point, but the interesting point, which is that this motion of the charges lower the energy of the charges in presence of these excitations. So the famous Lamb shift that tells us that the charges are almost at the level that can be foreseen by the Bohr model, the quantum electrodynamic model, neglecting vacuum, actually is a little less, 1 part per billion. Okay. Now, what do I want to show in this slide? In this slide, I'm just telling you that. Imagine, let's look this plot. What is this? This is something that tells you which is the variation of energy in this process. Pay attention. You have an energy, the energy 1, that is withdrawn from vacuum, in the sense that is an energy that is positive, in the sense that the process to excite the electron charge, for instance, around the water molecules, the process costs a certain energy that we call energy 1, okay? But, no, the fact that there is a coupling, no, there is this, let's say, this term of length that, you know, the movement of the charge, as we told, create a emergence of a field that opposite, no, to a current that coupled with the field and opposite to this increase of energy. Okay, and this energy is called energy 2, which is the nice, interesting thing. The nice and interesting thing is that the energy 1, that is the positive energy that here is plotted like a red line, is linear with the number of components. What does it mean? It means that if I have to move 1 electron with 1 photon, let's say, I have to spend energy 1. If I have to move 2 electrons or 3 electrons, I spend 2 energy 1 or 3 energy 1s. That is linear, okay? Is linear. But the energy 2, that is the energy difference created by the coupling between the electron movement and the electromagnetic field that provoked this movement, this term of energy is not linear with the number, for instance, of charges, but is proportional to the number times the square root of the number. So what can you see here? And I didn't tell you, because here is just here has just presented the algebraic expression. This energy two terms actually is negative, as I told you. So you have a positive energy that represent how much the movement of the charge cost, and a negative energy that tells us how energy is saved, let's say how the system, through the coupling between the charges and the field, can settle itself on a lower energy. Of course, if we are speaking of very little n, let's see what happens. This energy to term is in green and is represented by this curve that is exactly a function of n times square n. What does it mean? It means that at the beginning, as you can see, if I make the total energy of the process and I make the sum of these two terms, I build the blue curve, the blue plot. The blue plot, as you can see, what tells us? Tells us that when n is still small, you have still a positive energy. Can you see this? This part of the plot, of the blue plot, is major than zero, is bigger, is positive. What does it mean? It means that the process costs a net energy. So it's not thermodynamically favorable. To be sustained, it needs energy from the air, from the outside. And this is the famous regime of the laser that needs a pump. But if you do not neglect certain terms of this coupling that today I don't want to show you because the Hamiltonian equations are very complex, if you do not neglect and you take into account that there is exactly also the energy, negative energy, the energy 2, you can see that while the number of the oscillator increases, so you are moving on the horizontal axis toward right, the total sum, being this term, the energy 2, able to grow in module, no? More than the energy 1, because it's not only linearly dependent on n, but is dependent on n times square n. When n becomes bigger, at a certain point you have, boom, this crossing point. You have the transition of the system from a state where the process costs energy to a state where the process let the system to get rid of energy. So the system become much more stable because acquire a negative added energy to its state, original state, that is, could be the isolated, let's say, isolated molecules or the molecule in the vapor, that make the system more stable because the total energy, here it is minor than zero. Of course, each system will have a sort of critical threshold that is given by, here is just a simulation, so don't consider the real number. This is a plot that I made on a stupid software. The critical number is exactly that quantity of oscillator that once put together, now I will specify better what does it mean, put together, that once put together, they settle on a new state that has a total energy that is less than the original one, and that has a peculiar characteristic. The peculiar characteristic, now I will show you, is the fact that this negative energy is possible only if all the oscillation of these oscillators, sorry for the repetition, but only if the let's say in the example, no? Only if the electrons that we were considering, no, to be moved by the virtual quanta from vacuum, only if this movement are in phase. So once that these charges are oscillating under the stimulation, let me say, of the photons, the virtual photons, move in phase, move in the same, let's say, in a collective oscillation, that's the condition necessary and sufficient to engender a negative total energy of this interaction, the interaction between the electromagnetic field coming from the vacuum and the oscillation of the charges that it provokes. So, just to tell you, that's the reason why we are calling the total energy coherent, alias energy gap, as you will see. As you know, energy, of course, is related to frequency of oscillation, if you remember the Planck relation, no? In the sense that energy is the Planck constant time the frequency. The interesting aspect that I just suggesting here is the fact that if we are representing with omega q the size, here is in frequency, but is equal to the energy, let's say. No? In natural units, energy and frequency are the same. But if we are considering that this is the energy of the photon able to make the electron, able to make the electron transit to an excited level allowed by the molecular electron spectrum, let's say, no? If you have this energy, okay, once that the energy, the number, the critical number has been reached, what does happen? Happen that the photons that excited all the charges of the system will not ever be able to return into vacuum, and they will be trapped in the oscillating charges system. And this aspect will create a renormalization, omega r, renormalization of the original frequency of the photon. How this renormalization, how much is this renormalization? This renormalization is proportional to how, this is the phase term, see, is proportional to how, let's say, how good is the possibility to set a collective, let's say simply, set a collectivity, a collectiveness of the oscillation. So the more the phase is shared, no, among all these oscillators, and the stronger the renormalization will be. Why I'm speaking? Why am I speaking of renormalization to you? Why is it interesting for us? Is it interesting because the renormalization of the photon is exactly the reason by which it is self-trapped. Now we will see better. And the fact that inside an ensemble of matter components there is a self-trapped field is the condition that produces all the interesting phenomenologies that we can speak about, from homeopathy to living system, from laser physics to spectroscopy. So it's a crucial, also to, for instance, to solution of ions, to the trend with the temperature, with the electric, with the dielectric function of water, for instance. So many things are related to the fact that the systems of collectively oscillating molecules are trapping a field that is renormalized is the father, let me say, the father of many aspects. Just to show you the only equation that I will, very few equations, this slide is almost the 80% of the equation that I'm showing to you today. But just to tell you, it's very interesting to see this Anderson, the self-trap mechanism is also called Anderson, Higgs, and Kibble mechanism. Don't be frightened by what I'm saying, but it's very simple, and it's very simple mathematics. But it's very nice to see what happens. Imagine that the photon has a frequency, okay? That we are calling nu, with the Greek letter nu, okay? We know that this frequency, once that the critical threshold of the number of oscillation is satisfied, this frequency will be subtracted, by a term, the phase term, in order that it becomes smaller. And we call this new value of the photon, of the frequency, sorry, of the photon, nu CD, coherence domain. Now, after we will see. This is very, the fact that in vacuum, if we know that frequency is equal to the speed of light over lambda, the wavelength. Of course, once that this term nu has become smaller, has become nu CD, this we can put anything to the square, to the second power. Anything, this difference will be no more 0, but will be minor than 0. Why this is interesting? Because if we know that energy in quantum physics is for sure equal to the product between Planck constant and frequency, but is also equal in relativity, for instance, for the not considering the motion of a particle, but the rest energy is the mass times the square of the speed of light, and we know that the momentum is the Planck constant over the wavelength. Let's do a little algebra. We can say that, of course, energy, okay, the square, this is the equation, momentum, mass, and energy equation. So the equation would be energy to the second power is equal to m to the second power, c to the fourth power, minus, plus to momentum to the second power and the speed of light to the second power. We have just put, rearranged the equation, and we can write this in this way, So we have that this term, that is just the square of this one, is equal to the energy, but expressed in quantum terms, that is the the Planck constant times the frequency, minus, of course, the momentum times the speed of light. Okay, what is interesting? The interesting point in that is that if we take out the Planck constant, we know for sure that this quantity, as we told before, is negative. So what does it mean? It doesn't mean that this quantity is negative. But how can it be negative? Because the speed of light elevated to the fourth power is for sure positive. The only answer is that the square mass is negative. What does it mean? Mean that the mass of this excitation is imaginary. This tells us that we are speaking of quasi-particles. What is the quasi-particle? Is an excitation, is an excitation that is given exactly by the coupling. is not just a photon. It's not just an electromagnetic field like it was when it was when in vacuum, in the free vacuum. Is an electromagnetic field coupled to the charges of the matter. This coupling is the quasi-particles. This is the self-trapped photon, let's say. Now, let's see what happens in water. So we go easily. We consider the photoelectron spectrum, that is this one on the right, and we see that, as I told before, no? Imagine that from the fundamental level at which the electrons in the water molecule are, that is the sp3 orbital, as you can see, the first peak of absorbance irradiating a water molecules to let the electron jump on the next level, it is at a very high energy, because 7.5, let's say 7.6 electron volt is a already hard ultraviolet photon, let's say medium ultraviolet photon. As you can see from this spectrum, water molecule has a lot of orbitals that constitute actually allowed levels at which the electron can jump, of course, if stimulated. What does it mean? If absorb photons that have the sufficient energy. So all this transition, all these peaks represent the levels, the energy distance, no? The energy distance from the fundamental level of other levels, excited level at which the electrons can be pushed. You have exactly, actually, all the orbitals that are populable by the electrons, the 3p, the 3d, the 4p, the 3s, blah, blah. So, the point here is, and after, just to say, and after a certain threshold, that is after 12.6, and you, as you can see, here you have some very, you can see that here begin a sort of continuum band, very, very thickly populated energy regions. That means that, of course, you are going farther and farther from the water molecule, and the electrons are becoming more and more free, like as if, let's say, they were in the vacuum. So the point here is to understand if our molecule, let's say that in our case is the water molecule, will choose one of all these specific peaks to establish a situation where the electron is pushed on the excited level by a photon that has enough energy and relaxes to return to the fundamental, but in a continuous way, in the sense that oscillating stationarily between these two levels, two or more levels, because could be also more. The study that the great researchers like Giuliano Preparata, Giuseppe Vitiello, Emilio Del Giudice, Raffaella Rani, Ivan Bono did, and others, Luca Gamberale, Marc Henry, to refine certain teams after, what they did is exactly this kind of study to see if, starting from first principle, it is possible to describe a water molecule as a system, at least by default, in the sense not considering the temperature, but starting from a zero temperature system, because it's easier for the first calculation, to imagine if we would have a condition where the self-trapping of the electromagnetic field is verified. And of course, if it is verified, is because this condition gives an energy gap, a total energy of the system that is negative. So is a possible and thermodynamically favorable situation. I'll save you a lot of complicated mathematical calculation, but I just tell you that in the consideration of this process, many levels, as I show you, has been considered, many excited level, no, from the first one that I told you to the last. Or this is we could say that these are almost the orbital, almost they are all the orbitals of water, but there are also some virtual transition. What are the virtual transition? Virtual transition are possible transition that are intermediate between an orbital and another, that are unstable, metastable levels, but that must be considered. So let's see now for a minute the simple and almost stupid animation on the right. This is the water molecule. This is the electron. The electron is placed on the fundamental ground state. Imagine that this water molecule, imagine the process that I'm telling to you always happens. Nothing in reality is an object in itself that is not perturbed. The famous uncertainty Heisenberg principle is exactly something that represents the condition of being in a state that is impossible to be quiet. The condition that quantum physics tells us with respect to to classical physics is the fact that anything existing is condemned to oscillate. No, the uncertainty is exactly a transduction in mathematical terms of two possible ways of representing the things. The first way is that any object, let's consider the object is in oscillation. The second way to represent the things is that actually the object does not exist, because anything is just a smooth and blurred fading out and in of excitation, like a wave on the sea. If I tell you, guys, look at that wave on the sea surface, and you say, oh, nice, okay, and I ask you, where does the wave begin and when does the wave end? You can just make an approximation. You make an arbitrary cutoff of the wave. So actually, this second perspective is the more realistic, because an electron is not a ball. An electron is just an excitation of a field, exactly the same field of the electromagnetic field, actually. In fact, if you look at the Feynman representation, you can see exactly that the electron and is a continuous collapsing and emerging of virtual quanta. But let's skip this part and just try to reason in simplistic way, just keeping good the idea of the sticks and balls for a second. Imagine this is the water molecule. This is the energetic level of the fundamental, this is the energy of the fundamental level at which the electron is placed. Now, we imagine that a photon is absorbed by the water molecules. This absorption implies the fact that the electron is, boom, is shooted up on a certain level. Don't care about which is the level. The electron is excited, okay? Of course, this is an unfavorable thermodynamically speaking state, so the electron soon will relax and will decay back again on the fundamental level. This is exactly the process that occurs always. This is a virtual excitation. How long did it last? Very shortly. as expressed by the Heisenberg uncertainty relation. And as you can see, the photon, when the electron relaxed, the photon, of course, had been restituted, came back to the vacuum. But what does happen if this molecule, let's try to imagine, is very close to other neighbors, to other water molecules? That is exactly the situation that I was telling you about before. Imagine, that the critical number, do you remember the previous slide? The previous slide I remember here. Do you remember, when the number of the molecules overcome a certain threshold, the system enter a new state that see an energy, a negative net energy. What is this situation, physically speaking? Is this one. The fact that when the molecule, the water molecules, is close enough to other water molecules, these photons, when leaves the water molecules, has the 100% probability to be absorbed by another water molecules. So we'll never be able to come back to vacuum. Let's say just in heuristic terms. So above a certain number threshold, these photons will become, as I told you before, by the mechanism, Anderson, Higgs, and Gibbs mechanism, will become self-trapped. And you will have an ensemble of water molecules that oscillating together will keep inside their ensemble the excitation of the electromagnetic field given by all the photons that would have excitated all the electrons of these molecules. Do you have an idea of how high this number is? This number is of the order of millions of molecules. In fact, sorry if I correct a little Igor Yerman that this morning spoke about clusters or coherence domain. No, they are not the same thing. A cluster is something that is made of at maximum 100 of molecules or few hundred of molecules. The coherence domain can exist only when we are speaking of million of molecules. Exactly about, theoretically about 6 millions at zero temperature, neglecting the temperature. Now I will explain you why the temperature affects the number, but theoretically we are speaking of 6 million of molecules per each coherence domain. Now I told you a story in the term of sticks and balls, but we have to shift on a much more mature physical conception that actually is sealed and delivered by the Heisenberg uncertainty principle that, as I told you, in quantum mechanics, but let's stay for a while in the previous, that in quantum mechanics is read like, okay, we have the uncertainty because anything is condemned to oscillate, so we cannot know contemporaneously the velocity or the momentum and the position of a quantum object. But this is, as I told you, a simplistic version. That is a version that is given if we wanted to conserve, if we wanted to still be attached to the still classical conception of sticks and balls. Cioè, the idea that the electron is a ball, the molecule is a nice oscillator making of springs and balls, that oscillates and whatever, no? But actually, we have to consider a very important aspect that is expressed, now I will show you, in the uncertainty principle that emerge in quantum field theory and not in quantum mechanics, that is related to the fact that we are considering which variable? The phase. Because as I told you before, I told that coherence, what is coherence? Coherence is when oscillation of object is happening in phase. What does it mean? It means that if we can have two diapasons that emit frequency identical, for instance, the La note, but to be coherent, they need to be in phase. They need that all the waves, the wave maxima and minima are in the same point of space and of time. Along the time axis, you need to find the maxima of the waves at the same point. This is coherence, very simply speaking. Now I want just to tell you about a little the energetic, no? This is just a synthetic scheme that tells us this point. Here in red, you have the energetic, the fundamental energy at which the electron of the water molecules is about, because it's subjective to the perturbation of the PGS, is perturbative ground state. This is the level at which the electron is when the water molecule is alone. And when it is alone, as we saw, when a possible vacuum excitation arrives, the electron just make a jump and decay back within super short time lapses. But once we have that the water molecules are together, are many enough within a certain region of space that I will tell you which is this region of space, what does happen? What I told you before, happen that the photons become self-trapped, the electron so is something that continues to oscillate between the fundamental and the excited level, but the energy, the frequency of the field, that is the energy of the field that provoked the transition from here to there, is renormalized. Why? Because the field is getting slowed by the fact that spends a part of the time like excited matter in form of excited electrons. This is why, as I showed you before, we have the mechanism of Anderson-Higgs and Keeble, where the photon frequency is reduced. And this is created that, let's say, the ensemble of molecules which are coupled to this field make a sort of internal total reflectance of the field. Exactly because the refraction index of the system becomes bigger, and the field prefer to stay inside. But we told, no, they prefer to stay inside because the system where the charges are oscillating in phase among them, among one another, and with the field, is energetically more favorable. In fact, what can you notice from this scheme? The fact that the vacuum level at the end of the renormalization process has become the blue one, that, as you can see, is lower than the red one. And the difference between these two, old vacuum and new vacuum energies, is called energy gap. And if we consider also the role of the temperature that tends to set out of phase the oscillation, the coherent oscillation, we have for water something that is about 0.2 electron volt, but actually a little less, 0.16 electron volt. This is the result from the last calculations that has been made from by Henri, Gamberale, and others. Usually, or at least many times maybe, you have heard about the fact that water is a tetrahedron, water making nice hexagonal patterns, geometries, no? Do you know? Actually, if we look at the water as an isolated molecule, we do not see the possibility to have a tetrahedrical form, a tetrahedrical shape. We rather see something that resembles a potato, a potato-like shape. But this is the water molecule when it is and on the perturbative ground state. So when it just subjected to vacuum fluctuation in a perturbative regime. But when it is a part of a collectivity that has overcome the critical threshold, the number, the critical number, the situation is no more statically this one. The situation is a molecule that oscillates from the ground state, sp3 level, and one of the many levels that I showed you before. And just to let you know, if we do the calculations in the pressure and temperature conditions that we usually have, also liquid water, ice, whatever, the normal ice, let's see, the chosen level is the 5d orbital of the oxygen. So you have the electron of the oxygen that oscillate from the sp3 and the 5d, keeping inside a self-trapped field, and the average of this change, of this, this shape is the shape that the water molecule would have when the electron is pushed on the 5d orbital. This configuration is populated about the 10%, the 13% of the time of the whole cycle. So 90%, almost 87%, as you can see, of the time the electron that is spent by the electron at the coherent ground state. This is the fundamental level. The 10%, the 13% is spent on the excited. The time average of this oscillation that is a super fast dynamic. This dynamics is something that occurs at a frequencies that is of the order of fraction of picoseconds, or let's say barely 100 of femtoseconds. Femtoseconds is 10 to the minus 15 seconds. So the spectroscopy, infrared spectroscopy, for instance, that is the most used, also the near infrared spectroscopy that is even at higher frequencies, is shorter wavelengths and shorter resolution times, will be never able to see these dynamics and will always look at an average. And we always restitute to us a picture that is a sort of melange of what is occurring in there. Why? Not only because the frequency of the photons is slower than the frequency at which this change of configuration occurs, but also because the photon in the infrared, for instance, have a wavelength much bigger than the wavelength of the oscillation that we are speaking of. And let's say much bigger than the size of the coherence domain. So the photon, when is absorbed by water, we'll see not only one coherence domain, we'll see many coherence domains, maybe not in phase among them, and also, as we will see, the non-coherent fraction. But let's go step by step. And which is the important point that I just told in my last sentence? The important point is this one. I come back for one slide. Is the fact that the dimension of this object, that please, I'm saying object, but please do not think of the coherence domain like a ball, like a fixed ball made of a certain fixed number of molecules that you can take and handle. No, the coherence domain is just a region of space within the volume of the water that is as large as the wavelength of the photon responsible for the transition from the fundamental level to the excited level. So you can imagine that if, let's see, one of these, if the favorable condition would have the most favorable condition, then now I will just list a little to you. If the favorable condition, the favorable parameters to choose the coherent level had been for another level with respect to the 5D that is highlighted in orange, but let's say that could have been for another, you would have that the coherence domain are established on another oscillation, another level, and another size, because the wavelength is different. Which are the parameter important to see which one is the winner among the levels of water? The parameters are many. I just tell you the most simple ones. First of all, the critical density. That is nothing different but the critical number. What does it mean? It means that the density is just the critical number, just related to, instead of speaking with respect to the volume of the coherence domain, we are just speaking with respect to the volume of the system, the overall system. So what does it mean? It means that if I tell you that the 5D orbital has a critical density that is of 0.34 grams per cube centimeter, what does it mean? It means that when water is in the vapor state, for instance, above 100 Celsius degrees, let's consider ambient room pressure, 1 atmosphere. While I am cooling down the system, just imagine if the density, the critical density, were the only important parameter, the coherence would be settled on the level that has the smallest critical density, because it is the one that is encountered before than the other. No? While I'm cooling down, while the system is getting denser and denser, of course, if the density threshold is the only parameter, the least density threshold among the levels is the one that dictates which is the winner. Of course, this is not the only parameter, because as you can see, we have levels that has very as lower density thresholds, no? But we have the density threshold, the value of the energy gap. So how much energy the system gets rid of when passes from a non-coherent to a coherent state. Secondly, we have how much the photon frequency is renormalized, little or a lot. That is something that, of course, goes hand in hand with the energy gap. No? Other parameter, how much is the weight of the excited level over the process? Because if the weight is too little, you have a coherence that is weak. Huh? The amplitude, as A0 is the amplitude of the field, is the amplitude in module wide enough or is too little? Huh? And the term of the mass renormalization of the photon, the term that tells us, as I told you before, how negative the mass becomes, the imaginary mass, the quasi-particle, let's say mass, it becomes negative. And above all, the coupling constant, G, is the coupling constant between the charges of the molecules and the electromagnetic field. As you can see, you can have many values, no? Different values. So you have a sort of recipe made of all these ingredients that for us, let's make the 5D orbitals be the winner of the process. But as Emilio Del Giudice, Marc Henry, and Luca Gamberale told in their last publication, and Ivan Bono, that is quoted in this part of the slide, nothing prevents us from saying that at very extreme, let's say, at very different thermodynamic condition in terms of temperature and pressures above all, the winner level could be also others. And this is the case, for instance, if you think about how many types of ices exist, you can understand that the merging of several types of ices is also related to the election of new winner levels for building up coherences. Without saying to you that here we are just looking at the electronic coherences. That is, the coherences that can be buildable upon the oscillation of the electrons of the molecules. But another thing that you would learn if you will attend the electrodynamic in condensed matter course, it is that this kind of coherence is not related to the position of the molecules in space. This is why this kind of coherence is ascribed to the liquid state, where it doesn't matter where the molecules are in terms of ordered pattern. But you would learn, if you wanted to go deeper in this subject, that you have also other kind of coherence. For instance, the coherence established over the oscillation of the nuclei that are ascribed to the solid state, to the crystalline state. And in ice, in the crystalline states of ice, because not all the ices are crystalline, there are some kind of ices that are amorphous, like glass, you would have to add the coherence over nuclei or beyond the coherence over the electrons. So there is a new world that opens up by studying condensed matter in this way. Maybe I'm bothering you because you are interested in homeopathy, in potentized remedy, and you are thinking that all this story is not important for this, but actually this story is the key for understanding the dynamics of the potentization of and the fact that you can create just with the simple water beyond the Avogadro threshold, where you don't have nothing than water molecules, how can you create several kind of remedies? Cioè, I don't know if I'm explained well, no? The question that I'm asking to you is, let's imagine, when you speak of Arnica montana 2000 K, or Gelsemium sempervirens 200 CH, whatever, no? Arsenicum album 1 million, no, di potentization. You are much more expert than me in this kind of pharmacopoeia. But, no, you know very well, this is the problem that homeopathy has had to face for a long time, no? If we study if you study this system, you see nothing than water. The question is, okay, we have understood that water has a structure, but we have not yet understood that water has a structure, because what does it mean in terms of the mainstream chemical physics portrait? No, now we are beginning to explain this, but let's stay from here. What does it mean that water can be organized in a way that, despite the matter is always the same, that allows us to have different remedies, in the sense that systems that have different properties, despite the only matter, the only substance is always water. To answer this question, we have to say two more things about this simplification that I'm explaining to you, that are related also to the fact that has been commented by Vladimir this morning, about the fact that water is the molecule of life. Why water is the molecule of life? Now I will tell you a little aspect. The little aspect about water, about why molecule is the molecule, water, sorry, my tongue, about why water is the molecule of life, are embedded here. In this upper part of the energetic dynamics of the coherence. The point, let me see if the slide, okay, now I just tell you things more before than us answering to the question of why water, why is water the molecule of life. In the first instance, it is important that you shift your vision, shift your figuring out the system from this kind of stuff to this kind of stuff. We know that theoretically all the water molecules, no, enter a more favorable condition when they become coherent. But of course, at non completely 0 Kelvin temperatures, a part of the molecule is set out of coherence. And this part of molecules set out of coherence by the thermal fluctuations is the interstitial parts, a gas-like fraction of the system. So liquid water is at least a two-phase system. Let's have just a stupid scheme to have an idea about the, let's say, the distances. The coherence domains would be as big as 100 nanometers. Why? Because the wavelength of the photon that is responsible for the transition from this level to this level has the energy exactly of 12.07 electron volt And if you make the calculation, the wavelength is exactly about 100 nanometers. So the size of the coherence domains built on this oscillation, on this degree of freedom, is 100 nanometer, namely. But if we consider the temperature that, how to say, no, erode the boundaries, you will have something smaller. Actually, you will have something that is become at room temperature 60 nanometers in diameter, about. Here, remember, do not think of coherence domain as fixed balls. These are just a region of the space where the molecules are able to oscillate together. But these molecules are not always the same. These molecules are like the people in a square, in a city. Oh, in this city there are 1 million people. Okay, but no, it is not said that today the people that were yesterday are the same. No? Okay, of course. The coherence domains tend to be packed together. In fact, a thing that I didn't told you is that once that the molecules enter in a collective oscillation, they become more and more packed because they are by resonance, we will see this kind of dynamics attract among each other. But pay attention, due to the fact that the water molecules are oscillating, are passing continuously from a compact shape like this one to an enlarged shape of this one, at least for the 10% of the time, the average size of the molecules inside the coherence domain is bigger than the size of the isolated molecules. So the molecules inside the coherence domain are larger than the molecules of the vapor. This is why the coherent fraction is the so-called low density fraction of water. The vapor part, counterintuitively, is the high density fraction. This is very interesting because this explains how the density trend goes with the temperature. Why has water a maximum of density at 4 Celsius degrees? Because the density, the global density, is not given by an homogeneous system, so by one phase, but is given by two phases. So you have to contemplate that during the increasing of temperature, you have to see how the density of the non-coherent part changes, together with how, even possibly, the density of the coherent part changes. Actually, the density of the coherent part doesn't change. What that changes, the thing that changes, is the dimension of the coherent fraction. Because the more the temperature is risen, and the smaller the coherence domain become. At room temperature, you have that the 40% of the volume of a liquid is occupied by the coherent fraction. But if you go to higher temperatures, the volume, the percentage will be lower. If you go to lower temperatures, the fraction, the percentage of the fraction will be higher. Now, don't care of the equation. I just want to show you that inside a coherence domain, the field that is represented now in a normalized amplitude passes from one, so from the full amplitude in the center of the coherence domain, to 0, let's say, asymptotically, exponentially decaying out of the coherence domain. And this kind of decay is exponential. No? There is a, as you can see, look at here, the function of the field amplitude as a function of the distance from the center is represented as an exponential. As you will see, this gradient of field from the inner to the outer of the coherence domain is a key element for explaining a lot of properties of water, and also to make some consideration about homeopathic remedies. Now, just take in mind what I'm telling to you without getting crazy. Sorry, but now with anything will be clear in few passages. Anyway, just to be quick, what I was saying, yes, I was just saying that liquid water, no, as you can see, is something that is made of two fractions. So this is just an example of the density. The density to be calculated must be considered two terms. Okay, the density of the coherent fraction that doesn't change because inside the density is given by the packaging that is provided by the self-trapping of the field that doesn't change with temperature. This is a very important point, but I don't explain why. And the variation of the density of the non-coherent fraction that, of course, changes because the vapor inside the coherence domain change the density independence of temperature. So you have a very complex trend because you have a term that that change just the weight of it because it changed the fraction over the total volume, and another term that complementarily changes its volume but also is changing the density. So you have something complex that reinstitute to you this particular and irreproducible trend of the density with any kind of other model. This is a picture extracted from the thesis of one of the last students of Giuliano Preparata that made a thesis on the water. And as you can see, the continuous line is the trend given by the function of the model. And this is the only line that gives you the maximum of the density exactly in the first of all, it gives you the maximum of the density. That is already a very nice success. But it also gives you in the right point, about around the 4 Celsius degrees. And anyway, just to close the point, I will say very quickly that all the idea of the hydrogen bond has to be completely rewritten because the hydrogen bond is no more conceivable as a force among molecules, but it's just the results of the tendency of a fraction of molecules to stay in the potential pit that is the center of the coherence domain. Now we have no time to explain you better things. And one very important aspect that witnesses you about the fact that inside the liquid water a coherent dynamics is occurring is given by the studies given by the studies made by Antonella De Nino, Nicolari, and Frezza and Missori about the trend of the dielectric function with respect to the frequency in the terahertz regime. I want just to tell you, sorry for the quickness that I have to keep, the fact that in order to correctly model the trend of the dielectric function, both in the real part and in the imaginary part, you not only need to represent the liquid water like a two fluid model, not a two fluid liquid, that is the coherent fraction and the non-coherent fraction, both for the real and the imaginary part of the dielectric function. But you need also to perfectly model the last tail of the imaginary part at the higher frequencies. You need to add this linear term that is represented by this in term in the equation to fit the model, to fit the experimental data that are the red dots, the red circles that are overwritten by the continuous black line. And I'm closing. That is just exactly a terms that tells you that the Kramers-Kronig relations are not satisfied. What does it mean? It means that it's not possible, it's no more possible to establish a relationship of causality between the field that is incoming, that is entering in the liquid and provoking the motion of the charges, of which you are studying the characteristics, through the absorbing of the field that remains, and the motion itself. Like to say that the motion of the charges and the field that would cause this motion are contemporaneous. There is no more a sort of, there is a sort of non-locality that is possible only when you have phase relationship among molecules. I didn't tell you before the fact that inside the coherence domain, you lose completely the definition of the numbers because molecules stop to be like independent objects and enter a new state where they are a field and move as a one. And this is exactly the reason why within very short terms of within very short time lapses that exactly correspond to the order of magnitude of the coherent oscillation, you do not have the past distinguished from the present or from the future. Just right because the oscillation of these molecules in the coherence domain occurs all together, all at once. I stop here because sorry for my length, because Alex has to show you something. Now, after, just to tell you, I will go to explain some better certain points about the water in presence of solutes, in order to understand what happens on the potentized remedies, and some things about the living matter. Sorry for the length. Now I stop. Where is stop sharing the screen? I hope that what I told is understandable, at least.
Thanks, Paolo. But I can continue later because it's interesting. But okay, your mind works with mathematics. It's clear, but ours not too much.
No, but not so much to mathematics. Yes, it's reasoning by physics, physically speaking. Yeah.
But it's interesting to leave us to reach a stage of an uncomfortable stage of trying to understand everything. But the most important message, I think, that you told us last year, is that each particular aspect of the coherent domains concept were not created from a very fruitful imagination and our dream. It's each small part of this concept is created from a very huge and solid mathematical basis. So you could show it not just talking. It's about mathematics. Okay, no, you show it to us. It's very convincing thing.
Yes,
So this
I'm
is the
sorry
most
that
important.
the most interesting things that also relate to what Vladimir and Igor told before, I had not yet the time to present it because, you know, the presenting the concept of coherence, it's not easy. So I needed to go slowly, step by step, and I super simplified the path. But if you will have the patience, after I will show you very interesting aspect about the things that we discussed this morning can be grounded on the physical dynamics.
Okay, we can continue later. So Alex, please feel free to share your screen if you want.
Okay, so I'm going to build on what Paolo just said. I'm going to pretty much use a lot of what Paolo has introduced to look at the plausibility of homeopathy. And it's just, I'm going to try and keep it short because it's getting late here. And so plausibility in homeopathy. And I came to this particular model because I was looking for a way to explain homeopathy in coherence domains as presented by Paolo, are really a good tool to explain homeopathy. And I'm just going to show you how we can use what Paolo has given us to explain homeopathy. So my starting point is it possible to formulate a plausible theory of homeopathy? Because we are often attacked in homeopathy, and just to have to be able to say, look, there is a way to explain it, is very, very useful. So if you remember, if you go back to what is homeopathy and what it does as a medicine, then you needed to do different things. You need a medicine, so you need it to be bioactive. It needs to work on the patient or on the animal or whatever you're treating. It contains information. It has to be able to hold information. You know, homeopathic remedies there's like more than 3,000 remedies, so there's a lot of information. And we know that the remedies are made through this kind of weird system of dilutions and succussions, so these repetitive system of dilutions and succussions. So you need something that's going to work with these three aspects. And so that's just to recap a bit what Paolo just said. So the quantum coherence domains, they're about the size of a protein. So 100 nanometers is kind of the rule of thumb. And it's about the same size as a reasonable protein. So just to give you an idea of what it looks like, what in terms of size, it's not really a ball, as I'll explain later. But for now, that's enough. And it is very common in water. So it's not like something very exotic that you don't find very often. It actually would be very common in everyday water. So I'm not going to go into this because this is Paolo's stuff. So it's just the history. But that's Paolo. So I just want to say that coming at it from a different angle than Paolo, that there are such quantum effects in biology is relatively accepted. We know that there are massive quantum effects, say, in the photosynthetic system, reaching up to 20 nanometers. There's a book called Quantum Life, I can't remember, that is just exploring all these quantum systems. So that there are quantum effects on a relatively large scale in biology is accepted. And it's funny that when you look at water, then water which is super small, then somehow water is considered, well, the interactions between water are considered to be classical and not quantum. So the idea that there would be a quantum level of interaction between the water molecules, leading to domains of about several million water molecules, as Paolo mentioned. It makes sense on a lot of ways. So I'm kind of telling you about it from that angle, that from a physics point of view, physics of water point of view, and from a biology point of view, so biophysics point of view, it makes sense that something like a coherence domain exists. And then again, coming at it from a different angle, if you look at some discoveries from microfluidics, so microfluidics is when you want to make a lab on a chip, so you miniaturize micro reaction chambers, and you have channels to put your reactions into a chip such as this. The thing is that the guys who investigated this realized that the solutes, so the reagents you're putting into your micro chip, didn't come smoothly. They would come in lumps, and actually these lumps or nanostructures would be about 100 nanometer in diameter. And they found this for a whole range of materials, a different concentration, different solvents, as long as they were polar. Sorry, it's not there. So they need to be polar. That's the quantum coherence condition. And they could see that there's not nanobubbles, and they were quite stable. So these 100 nanometer structures are found in a completely different field, which is microfluidics. Another completely different field is that of femtosecond spectroscopy in Lausanne, and here they were studying ions in solution, so say calcium or in water, and they found that one ion affects water over 20 nanometers, so we're not 100 nanometers, but we're in the same scale, and that's equivalent to 70 hydration layers, so that's the number of water molecules in between. And so it affects about 1 million water molecules, and currently there is no theory within conventional science that can explain this phenomena. Actually, it's so striking from an experimental point of view that friends of mine who sent me this paper said, if this is true, then homeopathy is probably true, like purely because there is no theory that can explain this phenomena from a purely current physics perspective. Also, I want to point out that we are in a theoretical blind spot in the sense that often the debate about theory is resolved by just hammering it with a computer until it gives up. But in this case, the computer challenge is so high that we don't know how to simulate millions of water molecules on a quantum level. So we are in this kind of computer no man's land. So the traditional way of resolving the debate about these things, which would be just to compute the hell out of it, cannot be done or hasn't been done yet. So we are in an interesting place, this so-called mesoscopic scale, where we just don't, it's not been quite explored by conventional science. So now I'm just going to show you how we can use these quantum coherence domains that have about 100 nanometer across, how we can use them to explain homeopathy, how it works. So the idea is you would have quantum coherence domains, and as Paolo mentioned, they are vibrating all the time. And so an idea would be that they would be able to record their immediate environment, their immediate frequency environment. In particular, if they're close to a protein, they might be able to record the specific frequencies associated with, say, an enzyme's function. So every protein, particularly enzymes, have frequencies associated with their function. And we know we can affect their enzymatic rates by frequencies. So if we pump certain frequencies into a system, we can enhance or lower the rate of an enzyme. So here, the idea is that you would use these quantum coherence domains to record or to capture the specific frequencies around them and the specific frequencies associated with the protein side. And then, as Paolo mentioned briefly, there is a clumping phenomena with the coherence domains. And so similar quantum coherence domains that have the same information, we tend to clump, and coherence domains with dissimilar information, we tend to not clump. Oh. And so you would have a form of clustering in the system which would stabilize the information within these clusters. So now there's clusters of coherence domains. And so to show you why this system is important is that if you do a simple dilution, so you take your, I just showed you schematically the protein and coherence domains, and then you just put them in solution, and then you just dilute away, then after a while, well, you get nothing. And that's what all the critics of homeopathy tell us, oh, well, you know, you just dilute and there's nothing left, which is okay if you don't shake. But if you shake, what happens is that with the shaking, you can introduce enough energy to split up those coherence domain clusters, and they can then start to propagate around and replicate themselves around. At least that's the idea. And then, so in this way, succussion helps in propagating, in creating a homogeneous kind of information around. And so when you dilute this and you succuss it again, then you propagate the information as in the form of frequencies in the coherence domains, but you lose the protein. And this way, at the end of the day, you don't have the original substance, but you've retained the information associated with that substance. And if you give that back to a patient, then you can affect the frequencies of different proteins in that patient. So that, in a nutshell, is the idea of how you can build a plausible theory of homeopathy. It's a kind of model, of course, that is built on sound physics of water, as Paolo presented. Now, so that's kind of was my main aim in this presentation, is to really show you it is possible to build such a theory of high dilutions. It's not completely crazy, as a lot of people would assume. Now, I just want to go a bit further and say that when we talk about quantum coherence domain as little balls, we know this is a simplification. The reality is much more complex, and much more beautiful. And so this is the work of John Stuart Reid on cinematics, sematics. And I just put this slide there to show you that we should be thinking of water as a medium that's vibrating and able to capture vibrational information. It might be, it's better idea. So it might be a good thing to think about the problem as a quantum oscillatory quasi-stable structures. So that would be my take on the problem, that the information is captured in these quantum oscillating quasi-stable structures that are based on the mathematics and the quantum mechanics of coherence domains. And then we can introduce other things like dissipative structures, because indeed, as also Paolo mentioned, is these structures are probably not inherently stable. They need energy from outside. We've seen that in different experiments by Konovalov and by Montagnier and by others. So there seems to be a need for external energy to maintain these structures. A person you might know is Dr. Imoto, who passed away, but he left us these beautiful pictures of water crystals on the not nanoscale, but microscale. And that shows us the complexity. Here, I just wanted to show how much information can be stored in a water structure. So it could be very, very vast amounts of information can be actually stored just by the variety of water structures, water crystals you can get. Another aspect that actually Leoni researched is the propagation of information, so how information progresses within a water system. And the idea here is that if you have a water structure or a system that is like a cluster of coherence domains that is oscillating together in sync, and they're all doing this kind of dance, then water molecules that are a bit further away, neighboring them, might be able to start doing the same dance. And I think of it as if you have a neighbor that is having a party and they're playing a song, and then you recognize the song, then people would start dancing the same song because it's the music, the dance that goes with the music, and so it kind of propagates itself. So you might start having the party at your place, and then it propagates. So in this way, you can have the propagation of the party, so to speak, and you can measure that. So Leoni did some interesting experiments in lakes to show how this information can be propagated. We also know that this information can go through glass. So that's a very interesting phenomenon. It's so-called field effect. And if you leave a sample beside an informed sample, so if you leave a control sample beside an informed sample on the left overnight, then the other sample is informed, so to speak. So this has been looked at by quite a few researchers, as I mentioned. And we know it's kind of electromagnetic in nature because you can shield it apparently with mu metal. So again, all this is consistent with it being an electromagnetic oscillating phenomena by nature. So all consistent with it being caused by quantum coherence domain oscillating in some way. Also, I just wanted to mention that there's a very strong evolutionary argument to all this. Is if we think of the origins of life and the origins of the first cells, they, if this phenomena exists, that is at the root of homeopathy, then the cells would have learned to use it as a evolutionary advantage. So say there's a poison close to them, then the poison emits a particular set of frequencies or associated frequencies, and then actually it wouldn't be the poison itself, it would be the quantum coherence domain around it. They would send these signal, and then the cell could sense that and then just go away. And so if you think about what happens, then it's very advantageous for the cell to be able to run away from poisons and go towards food. And just to be able to have this constant feedback from its immediate environment. And we can imagine that as life became more and more complex to us humans, actually we didn't lose that ability. We are still completely able to interact with our environment. We do get information from our environment. That is why we're still also so sensitive to homeopathy. So that would be an argument. And an interesting thing came from people looking at the olfaction system. And here the idea is that currently still most of biology believes that everything is kind of lock and key. You have a molecule and an enzyme, a molecule and a receptor. And that's everything has to be in contact in chemistry, it's biochemistry. But actually some experiments show that there's a vibrational component to this. And here's an experiment on flies, and it turns out you can train flies to recognize different smells. And the funny thing is that they can tell apart deuterated from undeturated odorant. And what that means is when you deuterate something, it just means you replace the hydrogen atoms in a molecule by a deuterium. And deuterium has one more neutron in it, and it just means that in terms of chemistry, it's got the same chemistry, but it's got slightly different frequencies associated. So the two molecules are identical chemically, but they have different associated frequencies. So it seems like the flies can detect a difference that is purely a frequency difference. Similarly, so yeah, I told you about the lock and key, but it also appears that humans can also detect this difference, so we can train ourselves to detect these differences. Again, that humans are also able to detect differences in frequencies, not just in the biochemical lock and key mechanism. Another interesting thing is if you look at cell receptors, then there was a very interesting experiment where with basophils, where they knew the system was sensitive to histamine. So histamine is the molecule associated with allergy reactions, and so you could test the system with histamine. And then what they did is interesting. They blocked the histamine receptor using this molecule called cimetidine. And when they did that, it stopped the effect of homeopathy. And so that would indicate that homeopathy is still acting through that receptor, so that that receptor is sensitive to the signal of homeopathy, to the frequencies from the histamine homeopathic compound. Again, indication that our biological systems are not just lock and key biochemistry, but have a lot of frequencies components to them. Yeah, so that's one. Yeah, so I mean, I'm much faster. Sorry, I mean, it's good. So it is, in my view, very possible to formulate a theory of how homeopathy works based on these I call them water-based structures, because we've got the water coherence domains that probably form superstructures. There's probably ions involved in stabilizing the structures themselves. So it's going to be quite a complex thing at the end of the day that is built to explain homeopathy, but all based originally on the quantum coherence domains. These things are actually very common. We shouldn't think them as exotic, or they are to be found in everyday liquids, and they don't have to be. Actually, they shouldn't be ultra pure. It's just normal. They are probably very interlinked with life itself and the origins of life, and they would be able to record complex information in the sense of these complex patterns of frequencies I tried to show you. And then because they have this information, and then can be bioactive and be useful as a medicine. And so that's, sorry, I went very fast, but so that's my message. I just wanted to show you quickly how I think we can have a plausible theory of homeopathy. So I don't know if anybody has some questions, since I actually went very fast. If there are any questions, no?
Alex, I like the way you present your talk and the images, and how clean and simple so it's very, very easy to understand. It's very didactic. It's nice. And
Thank you.
it's how it's important you to be the last one, because you resume everything in a whole set.
Yeah, I hope I didn't go too fast.
Put all together since Igor Yaman this morning to now, we can put all together and see how it's simple.
Well,
it seems to be complex, but
my message is I emphasize the simplicity. We need all the complexity that Paolo brings because that's the underlying theory, and it needs to be. It is intrinsically complex, the underlying theory. I'm stressing how simple it can be in terms of explaining homeopathy afterwards. So yeah, so that's why, yeah. But I'm just using the tools from Coherence domains, and these are inherently complex.
I have a fundamental question to both of you, just to start discussion. And when I say frequency, this frequency comes from the oscillation between the grounding and the excited stage, or not? It's like this or no?
So there is that frequency. I mean, Paolo can answer better than me.
Yeah,
So
yeah.
there's the inherent coherence frequency.
It's the same. You can, but it pertains to the part that I had still to show, in the sense that when I told you in this upper part of the of the energetics of water is the answer about why it is the molecule of life, and about how can you build several remedies with the same substance. This is something that we have to see, in the sense that we will see that in that gap, in that space of energy, we have a lot of allowed collective levels, and this is actually the possibility of water to oscillate on different modes. So independence of which is the solute that you started, with which you started in the first dilution, you affect the level of the electrons chosen, and you can have like a note, you make something like E or other. Actually, there are families of frequencies, but just to make a simple example.
Yes.
May I add something? First, I'm very pleased to Alex, who said a lot of interesting things. But what I would like now to stress, you see, our problem, and also, but even more, the problem of students, is that when we started to talk about oscillations, frequencies, resonances, and things like this, if we just take a look at our system of education, our system of education is based on idea of material things, which are, you just used the word solid, which are solid, so to say. And these material things affect each other by collisions. So, in fact, and Alex mentioned also that about the major principle of biological regulation on which biochemistry is based, that is key and lock. It started from Ehrlich, more than 100, a very good analogy, very obvious analogy of the more, there is a more scientific explanation, complementarity. So you have, for example, a receptor, and you have a ligand, and this ligand fits into this receptor. Well, exactly, key and lock. And I try to explain my students now that we got already for about 20 years much a very new analogy for key and lock. When I open my car, and students also open their car, it's now very rare when they use this metallic key and they put it into the lock of the door in order just to open the door of the car. They push the knob on their key, and the car may stand at the distance of 100 meters, 200 meters, and so on from their key. And only their car is open if the key really works. So the same, you use a bank card also using, so this bank card is also a key. And when you just simply put this bank card into the hole, into bankomat, so you get this money. Only your card, it works if it's not expired. This is also key and lock, as a matter of fact. And we use this key and lock much more often than we used things for hundreds of years, the metallic key and metallic lock. It was a very good analogy many decades ago, this key and lock. But there is a great difference between these two analogies, old key and old lock, and this contemporary key and contemporary lock. You can open your car using this, this electromagnetic wave only if your car is excited, if the accumulator on your car is just full. If the accumulator of your car is dead, it will not work at all. Same with the car. Well, you can use this key only when the receptor, when what you are opened is in an excited state. When you use the old analogy of lock and key, in order to perform the action, you need to apply force. In order to open the lock, you need to apply force. Here, you don't need to apply force because the energy of your key is incomparably lower than energy of the car which you need to open. So here is the analogy which, from my point of view, may try to explain what is the difference between the material idea of regulation, of this complementarity, or based on as a matter of on force, than this electromagnetic kind of regulation. We use it, but we just the greatest majority of us never think that when we use these resonances, oscillations, and things like this, we can send this information to great distances. Like, for example, we can regulate the devices on Mars planet using a small quantity of energy on Earth. And we can give the commands in order just for this device to move on Mars, on other planets and so on, to do something, to send us back information, what it makes shots and things like this. So the difference is that engineers who devised all these things, just basing on quantum physics, as a matter of fact, it is the foundation of what the new notion of key and lock is, quantum physics. And we, biologists, chemists, and so on, are separated. Our notion is notion of the 19th century. And we teach our students this physical chemistry based on 19th century ideas. Now we're in the 21st century, and 20th century just passed by for biology, for medicine. So there is no quantum physics in contemporary biology, medicine. Well, not only biology, medicine, but in meteorology. Well, in all these real things in which we live. You see, there are only this gadget progress, which we don't understand because we never studied all these principles of oscillations, of frequencies, of resonances, how they are important, and so on. This is the greatest, from my point of view, greatest problem of education. Not only just for students, because they are practically are not given these ideas, but even for us, because we also were educated. I mean, I mean, biologists, medical, biomedicine people, and so on. I'm not meaning physicists like Paolo, who can so easily use all these notions. For us, it is really very difficult. And first, we need to realize why it is so difficult understanding for us, because the basement, we should change the basement of our thinking. There was some time ago, there appeared a paper entitled, "There are no particles, there are only fields." You see, and the thing, yes, and it is not so how it's field, you see. Is it a field? Yes, in fact, it is a field. Simply, this thing is based on tremendous tremendous spectrum of frequencies. And some frequencies, when we're talking about, there was a question about here, solid things. What are solid things? Solid things are very, already from my just feeling, understanding, is of extremely coherent domains. That was, I was taught by Emilio Del Giudice, this understanding. What is a crystal? What is a solid thing? It is extremely coherent. So it is coherent, it means it is so tightly in resonance that you cannot break it down with frequencies which are of much lower frequencies. That's why it is solid. You cannot penetrate into this thing, because it is, Paolo will improve what I'm talking about. But that's my understanding. And the thing is, for example, I can penetrate into something if the frequency of my action fits into the frequency of where I penetrate. So that's and we have to change our understanding of things and fields. Things are also fields, but of different, completely different frequencies. Now, when they begin to resonate, then they begin to interact, or they can attract each other, they can bind to each other. And we are talking today about these coherent domains, about the unification of these coherent domains and things like this. So we should begin to think about how important are frequencies. As a matter of fact, we are just talking here simply because we use frequencies. We can talk, I mean our speech, I mean the transfer of information here from Moscow to Sao Paulo and back, you see, only thanks to frequencies. So, and we just built something, I mean that we begin to build new knowledge basing on frequencies. So we should realize that the activity, any activity in this world, and in the first place, intellectual activity, is based on frequencies. Now, also these frequencies should not be considered in a very primitive way, the most simplified way, like sinusoidal oscillations on flat surface and so on. As a matter of fact, the John Reid has a very beautiful picture of a violinist who is just playing a violin, and sound is a set of bubbles. It is not just it's not just the sinusoidal oscillations. These are three-dimensional, four-dimensional, because it's also in time, four-dimensional some entity. And just looking at this entity, we have to change our attitude to the world. It is very, very difficult, because our imprinted in us, our education is not enough to understand this. But you see, we are human beings, so we can use our imagination and reasoning in order just to start thinking in new direction. And then it becomes very simple. It is very complex, you see, like if we believed in flat Earth, it would be impossible to understand all these cosmic flights and how it can it be, how it is possible to fly from Moscow to Sao Paulo if we were based on the model of flat Earth. Now in biomedicine, we are based on a model of flat Earth. And it is much more three-dimensional. It's not just flat. So that's from my point of view. And it is, thank you very much for such just course, because it, I just received myself a lot from just not from my talking, but from talks of my colleagues and so on. And I hope that students also, probably it's very difficult for them to get the details of what we are talking about, but I believe that people never forget. They begin to, they get some knowledge and they will start to process it and combine it with their own experience and become this, make this experience richer and richer. That's what I wanted to say. Sorry for probably long speech, but I hope that
it's completely true. It's very important, Vladimir, because this is a very dense and not easy class. Today was hard, I know, but we don't want to make students learn everything, understand all the slides, and have every. No, it's possible, but just to do an print, say, look at this. It's we are all of these stuffs are around us. You have just to pay attention and start to see it in our day by day journey, etc. And also in our research projects, etc. It's just you know, it's there's something there, and we are not creating histories. It's real, and we have to learn more about it. Even me, I think this is the 4th or 5th year I do this kind of international discussions in this discipline. I learn many things every time. Today I note many things because it's always, you know, as a recursive learning. Because the second time, the third time I listened Paolo, but new things happen in my mind, and the fourth way time it to be the same. The fifth way, it's you know, it's a kind of a spiral way of building knowledge. You go around, you have the sensation to get the same point, but you are upper in relation to the previous round. So it's like this. This is the intention. So we can just relax, and even if pick up just small information, it's more than enough to start thinking about it. That's the goal. Evelyn, if you want to start.
Yeah, I can try, but Vladimir is working in this for years. Now it's very difficult. It's really a challenge to get it accepted or funded at all. There's only a few foundations who have enough money and are willing to fund this. That's why the whole idea is to become stronger together, to build a good foundation, like Vladimir is saying. Paolo is helping us build that, like a theory behind everything, a new language, so that we can really present it as a solid science, because many people don't understand it, but then the translation of the science is important. So can people understand what Paolo is saying? So how can we build that? So there's a lot of work to lay the foundation and the different steps before we probably can create some kind of master course. But at the same time, Vladimir is doing it in his university, so he is presenting some kind of water science in his course, and that's only because he's probably a very good, well-known professor, and they're not kicking him out just yet. I don't know. Vladimir can say about it, but even like Jerry Polak, he has difficulty to present this in his own university, at the University of Washington. He has a difficulty to keep his lab. funded and going. So it's a real challenge, but at the same time, there's so many people in the whole world interested in it, and they're using these technologies. They're buying it. So I think the movement will come from the outside, and that's why I also hope the World Water Lab, we can work a lot with these entrepreneurs and companies so that they can see that they need the science, and we can perhaps get funding from them to build the strengths for science. And I mean, in Brazil, Leoni is doing it, but that's also, Brazil is a different country, it seems. So it's possible. And or maybe Leoni has difficulty too, but it seems that in Brazil it's more accepted to do this. So yeah, if you want to help and think with us, join us.
So we can. It's a difficulty, but it's also a privilege, because we can do interesting things, spending almost nothing. Because, for example, our model with Artemia salina is nothing. It's very, very few amount of money in Brazilian reais. If you convert it to euros, it's nothing. And we can get many, many interesting and new results, and do good publications, etc. So it's, it's you don't have to. The quality of your research is not directly proportional to the amount of money.
Yeah.
It's
sometimes it's reverse proportion.
yeah. Yes. For example, Paolo, she works with his mind and his computer in mathematics. The cost is almost zero, I think. But you see how many.
But he needs to eat.
Yeah.
Good, not junk food. That's the thing.
Yeah. And so I have to, as another myth, we have to pay attention. It's not to. I cannot do many things because I don't have money. Wait, because you have.
Yeah.
There always a possibility to start doing something, and then money comes if it's necessary. Paolo, please, you are talking.
Okay, sorry, I wasn't sure that you told me to share the screen. No, just to.
Okay, that's good.
Just to give some fundamental last hints, because you have a lot of questions that I think that can be answered in the remaining part that I hope that also Vladimir can listen. In the remaining part that I'm going to show very quickly and schematically. Leoni, you heard me also other times, and you know how this subject is vast and should be, deepened in each point. But just to give the main points. If we understand that liquid water is not a random system of stochastic molecules that are just interacting through electrostatic bonds, but is a biphasic system where a part of the molecules is experiencing collective oscillations, we can make some important long-lasting excitation, collective long-lasting excitation. We can make some important deduction. I think that I didn't. Maybe I should. Yeah, exactly. Should show before this slide than the one that I'm going to show you. Give me a second, because otherwise it's not easy to discuss. Okay. Wait a second. I told you before that here to answer, we have to answer two short important questions. why water is the molecule able to create several kind of systems that, for instance, we call remedies, being always the same substance, and why it is the molecule, why is it the molecules of life? You have to know that in this part of the energetic, there are very interesting characteristics, very interesting features, in the sense that, as you can see, the excited level, that is the 5D orbitals, that is chosen in liquid phase for the oscillation of the electrons, is very near, very next to the ionization threshold, just half an electron volts of distance. This is a first important characteristic because, like Vladimir told, in living being, the fact that water is a reducting substance is the key point for maintaining our bioenergetics far from putrefactions, for instance. We need oxyreductions reactions. To do oxyreduction reactions in a situation, in a system where the most of the molecules are covalent molecules, is hard to explain, because who is the substance able to give electrons? How electrons can be transferred easily from here to there, also in photosynthesis? The answer to this question is water, but not water in the conception of the molecule. Water in the sense that the coherent fraction of water. The coherent water, why? Because the electron in coherent water spend 10% of their lifetime close to the ionization threshold. It means that for each coherence domain, you have about almost 1 million of quasi-free electrons. It means that with just a fraction of an electron volt, that is even smaller than 0.5, because it becomes 0.4, you have electrons that are easily seizable, easily donable, how to say, givable, okay? This is a first important characteristic that allows to water to be the molecule of life. Because in photosynthesis, when you have long-lasting electron packets that travel huge distances, like some nanometers, that for an electron is a lot, and without being without decaying thermally, maintaining their excited state, it's possible only because there is some medium that is protecting this travel, is protecting this excitation, and is maintaining their in the excited state. Now we understand that this medium is the water, the coherent matrix of water that keep electrons near to the threshold. So they are easily, with little expenses of energy, transferable and releasable. First point. Second point, in this narrow space between these two levels, water, as if you remember what I showed you when I showed the picture of the photoelectron spectrum, when I told you that after the threshold you have a lot of continuum, almost a peak, very, very thick. The peculiarity of water is that in between of the 5D level and the ionization threshold, you have a lot is just a representation, is just a scheme, a lot of allowed levels that can be occupied by the quasi-free electrons. What does it mean? It means that when you have the coherence domain, you have that a cloud of electrons. It's like to say that a cloud of electrons that correspond to the 10% of the total electrons is moving on the surface, after we see Y on the surface of the coherence domain, ready to be exchanged because they are very close to the ionization threshold. The ionization threshold is that energy level that, if reached, implies the fact that the charge is lost. The electron goes away. In this between, you have a lot of allowed levels. Allowed for who? Allowed for the electrons that are experiencing the coherence, in the sense that they are already living at this place, living in the excited level. In quantum physics, the particles are not distinguishable. So it's, of course, the electrons could be not always the same because they are oscillating, but it's like to say that the 10% of the electrons is available to be settled on one of these levels, okay? Together to the other. What does it mean, this fact? It means that we can have coherence domains of the same water, but having oscillation frequencies that are not that can be differentiated. You can have the oscillation of the electrons that is from here to somewhere here in one of the many of these levels. This is equal to say that you can have as many kinds of water as the levels. These levels are uncountable. Their energetic spacing is of the 10 billionth of electron volts, with frequency differences that are of the order of the kilohertz. So we are speaking of very, very tiny electromagnetic excitations in the range of the long radio waves. This point, it seems that is not so crucial, but actually it is, because allows us to understand. Sorry, because I'm looking for another slide. Allows us to understand that we can have a lot of possible configuration of waters, many configurations of water, just changing the boundary condition by which it is, to which it is subjected. So just to show you better the energetic process in this hierarchy, we can see that the oscillation over the levels within the molecules give us the possibility to build up what we call coherence domain among many molecules. But the existence of many of these levels here in this space allow these objects that are called coherence domains to oscillate in suitable conditions that I will tell you in a while, to oscillate among this level. What does it mean? That the collective system of electrons can periodically pass from one to another of these levels cyclically and stably. This is the first level of supercoherence, that is a coherence among domains. Okay? And we have a lot of levels of this kind. We can have several steps. Look at the frequencies. In this step, we are in the frequency of the infrared light, 10 to the 13 Hertz. In this second passage of the supercoherence, we are already in the range of the kilohertz. A huge scale transition step has been done. because if it's true that the wavelength of the excitation gives us the scale of the system, that is the wavelength, notice that we passed from a wavelength, from a spatial scale, a space scale of 100 nanometers to a space scale of thousands of kilometers. And if we go to the success, to the next step, we are speaking of scale coherence that cover lengths that are as long as the circumference of our planet, because these are the same wavelengths of the Schumann modes. Few hertz. The oscillation of our brain are in this range and are matchable with the length, with the wavelength of the stationary excitation of the electric field trapped between the ionospheres and the Earth, the surface of the Earth, the crust. I don't know how to say, crosta terrestre in Italian. I don't know how to say in Portuguese or in. Okay. As you can imagine, the fact that coherence extends over larger and larger space scales is something that has some, sorry for repetition, has something to do with life, because life is a collective phenomenon. And through this model of water, we have a complete revision of also the dynamic of evolutions. Evolution is not like Darwin told. It's not the selection of a species, but is a hollow movement, a hollow motion of the whole web of life. The ecosystem evolves and the species change in consequences, not the selection. To have a selection, you should have, first of all, random mutation of the genome. That is the first bullshit to be said, because you cannot have random fluctuation where the matter of the living matter is completely coherent. There are no random molecular encounters, no random mutation in the DNA. Anything has a biological sense. Anything is driven by the relationship with the environment. Secondly, you should have mutations that should be verified in many elements of a species in order to be characteristic in the genome that can be passed through this to the next generations. Because if the mutation is of just one individual, it cannot be passed in very few passages. It is lost. So you should have also the probability to to make two individuals that had the same random mutation mate each other and give and transmit this mutation to the next generation. If you make the calculation of this probability, you go to the 10 to the minus 64. That is something that, as you can see, is completely far from the phenomenological experience that we can have about the fact that the living system evolve perfectly in adaptation of the environment and not in a random way. So just to continue the point, I will come back on this point after. I told you this point. Let me show the next passage because it's very important. Sorry because the presentation is completely scrambled. Okay. Now let's think about what happens when in water. Okay, I told you that the supercoherence occurs when coherence domain, let's say better, when the collective electrons on the surface of the coherence domain can oscillate together on several levels of the on the several levels that I showed you to exist in the space, in the energy spacing between the ionization threshold and the excited orbital of 5D. This oscillation is possible only if the coherence domain can do a thing. The thing is to absorb energy and the collective electron upshift their level, but also to release energy, but not in a random thermal way. And this is not possible if there are no other partners in the environment able to receive this energy. Because being the collective electron coherent, they cannot relax thermally. They cannot lose energy by friction. So the coherence domain cannot lose energy, but if not through free energy, through releasing free energy. What does it mean? Releasing electrons or releasing quanta of electromagnetic field, that is photons. It cannot release energy by losing heat, okay? It's not subjected to heat in the sense to the coherence is something that below certain threshold, of course, is preserved. The threshold that is as big as the energy gap. If I give energy to the coherence domain that is bigger of the energy gap, one water molecules exit of coherence. So you see that to get out of coherence, I need to spend energy because coherence is a more favorable state, thermodynamically speaking. Now, to have possible partners that are able to receive the energy that many coherence domains could release means, in the most of the cases, to have solutes, other molecules that are able to resonate with water. First of all, if this is the picture of water, we have to know that by default, the solutes cannot enter the coherence domain, because to enter coherence domain, you must be a water molecule, because you must oscillate like a water molecule. So in first instance, the solute are in the non-coherent fraction, are in the interstitial part of the liquid. This is why the higher the temperature is, the higher the solution power of water is. That is a completely unexplainable thing within the mainstream chemical physics, because the power of the solution, the power of dissolving, let me say, the dissolvent power of water is explained by the capacity of water to screen charges, no? To solvate ions, for instance, and avoid that their charge electrostatic attraction put them together again. But this screening is explained through the dielectric function of water, the electric constant of permittivity that macroscopically is about 80. It means that once the ions are in the water, liquid water, their electrostatic attraction between anions and cations is dropped of 80 times. Yes, but how this electrical permittivity can emerge? In the old picture, this electrical permittivity is imagined to be present because of the dipole of the electric water molecule. So the electric dipole of the water molecule. But if you make the calculation with one single layer, that is the necessary beginning of the solvation of ions, you just find that the electric constant is just 12. And this is not sufficient to screen the ions reciprocal attraction that is very strong. Now, of course, I'm simplifying because I should show you a full chapter about ions. Evelyn and Leoni knows, but just to tell you that there is the great problem is that if I raise the temperature, the electric permittivity get lower. So how can be possible that rising the temperature, the water is able to dissolve a bigger quantity of, for instance, sodium chloride? It is not possible in that picture, but it is possible in this one, because in this one you understand that ions are placed in the non-coherent fraction. So rising the temperature, you are increasing the available volume that ions can occupy. Okay, just to tell you also how many trivial everyday things can be explained in a very coherent, sorry for the repetition of coherent, in a very consistent way. Okay, let's prosecute about, let's go on this, the problem. Solutes are in the interstitial non-coherent phase. What happens if we have to consider that each chemical species before is a physical species. Each molecule, each ions is something that, first of all, has proper modes of oscillation, proper frequencies of oscillation. Well, when these kind of parts are immersed in water, we have to consider their frequencies. If we have a molecule A and a molecule B, we will see what happens when the frequencies are of a certain type. Sorry, what happens? Go to the end of the presentation. Sorry. Okay. Imagine to see the coherence domain from a side. And imagine I just flattened it like a pizza. And imagine to look at the pizza from the profile. I don't know to say. We understood that the electromagnetic field is an amplitude gradient from the center to the boundaries. So it means that the field decays exponentially from the center to the periphery. In physics, when you have a gradient of a field, you have the developing of forces, because the force is the derivative, is the gradient of the field. If the field is denoted with the letter A, we understand that we develop forces, two kinds of forces. Static forces that does not depend on the frequency of oscillation of the field, and dynamic force that does depend on the frequency of oscillation of the field. Let's start from the first one. What does tell us this equation? Very simple thing that I have already told you, but now it's clear better why. This force is telling you that any charge, electrical charge, that is denoted by the letter Q, is pushed by the minus sign, is pushed outward on the periphery with a force that is proportionally inverse to the mass. What does it mean? It means that electrons that are much lighter than protons and nuclei are pushed much more strongly outwards than nuclei. Does this point matters for biological matter? Yes, a lot. Because this tells us that when a molecule arrives on the surface of a coherence domain, it is super stretched because the electron of the molecules are pushed outwards much more than how are pushed outwards the nuclei. So the molecules develop a strong electric dipole because the electrons are stretched outside. This provides to the molecule a big reactivity, instability, okay? But let's ask a previous question that is even more important. How that molecules arrived on the surface of the coherence domain? The answer to this question is given by the second force. This equation is telling us this fact. In this equation is represented the interaction force between a K substance that I called K, okay, a K molecules, and the coherence domain. The coherence domain is oscillating at a frequency that is called omega 0. The substance K oscillates at a frequency that is omega K. This equation is telling a very simple thing. It's telling you that when these two frequencies are very similar, this term above the fraction at the numerator becomes zero. Becomes more and more zero, more and more the frequencies are equal. Can you see? The same things occurs in the denominator, in the terms below, in the fraction, but faster and in the sense much more rapidly, because here the squares of the frequencies are elevated to the second power again. So what does it mean? It means that when the frequencies between the substance K and the coherence domain are equal, tends to be equal, the term, the denominator goes to zero much faster than the denominator. The numerator, sorry. Denominator and numerator. It means that this fraction gets to infinite when the frequencies are equal. It is called a divergence, and it means that these two molecules, the molecules and the coherence domain are attracted to each other. It means that the coherence domain, when have a frequency that is equal to one of the possible proper frequencies of a molecule, this last is attracted to the coherence domain. Is it clear? Okay. This is a very important aspect. Why? Because tell us how in biology you can have selective reactions. How is it possible that a cell attract the correct reagent in a chemical cycle in the right moment? Look at this animation. The coherence domain actually is a field of water molecules that are oscillating with the stationary wave of the self-trapped excitation. So, if you consider a system where you have several species of molecules represented by these several colors, can you see that this stuff is vibrating? Okay. If you see if you consider several kind of molecules, several species, like in in a cell, you have acetylcholine, you have the lactate anion, you have the glucose, you have the pyruvate, many things. When the frequency of the water is omega 0, if we have some molecules that have a frequency very close to omega 0, let's see omega 1 and omega 2, this is what happens. Only the resonating species are attracted to the coherence domain and bring together, bring close one to the other. This is exactly the same equation that I showed you before, just considering two molecules. Can you see? You have that the frequency difference between the two molecules, when is similar among each other and similar to the one of the coherence domain, this force diverges to infinite and a strong attraction is manifested if the sign of this equation remains positive. Positive. This is very interesting, because here you are explaining how modulating the frequency of oscillation inside the cell, you have that only the correct reagent in the biochemical pathways are meeting among each other and not randomly. There is no possibility to random encounters in living matter. That's a very important shift, because the whole molecular biology still thinks that the molecules inside the cells meet among each other random, through collisions. But this is completely false. Which collisions? Which collisions? What kind of collision? You cannot have any kind of collision inside a cell where all the water is coherent. Any kind of interaction, any kind of meeting is driven by water. The second passage, as I told you before, is that the molecules, once that they are on the surface of the domain, they are condemned, let's say condemned, to react, because they are settled in an unstable state because of the static force, also called the ponderomotive force, because pushes outwards all the electrons and stretches these poor molecules, polarizes them, provoking their instability and their ability to take or give electrons and make oxyreductions. So molecules are selected by electrodynamic forces and are destabilized by the static one. Here, it is the reason about how biological systems can perform oxyreduction so efficiently and so quickly. Let's try to look at these dynamics in the film, in a movie, and not statically. Try to see this this process dynamically. Imagine that we have a certain initial frequency of oscillation of the coherence domain of water that we call omega I, that is able to attract some molecular partners able in this condition to resonate with water because they have the frequencies similar to the one of the coherence domain. As you know, these molecules are attracted selectively. They are pushed to react, but what does it mean to react? To react means that the coherence domain catalyzes this reaction For instance, by seizing electrons, making a donor, or seizing a quantum of electromagnetic field, a photon. What does it mean? It means that once that the coherence domain allowed the molecules to react and became a product, it changes the frequency from the initial value to another value and changes the pattern. And now the frequency that is able to call other partners, it is another one. So other partners are called to react, and so on. This reaction make the coherence domain change again, and we have a next step. Imagine this stuff in many steps, and you can build the Krebs cycle, for instance, and all the cycles that typify and characterize biological functioning. There is no biological activity that is not made of chemical and physical cycles. And paracrine, endocrine cycle, seasonal cycle, circadian cycle, the cycles inside the cells. Anything in biology is a cycle. Why? Because any oscillation is a cycle. So when you have coherence, you have a continuous existence of cycles at several scales, at several levels. I put the semantic patterns is representing the coherence domain just to yield as much as possible the idea that, can you see, we have a lot of possible configurations of water thanks to the fact that you have those manifold levels in the space between the ionization threshold and the 5D orbital. So you have many, let's say, intonations, many tunable note of the coherence domain. So having different frequencies, you have different stationary waves, different semantic patterns. Do you want to know a thing? I think that spectroscopy, when we have an infrared beam that invests a volume of water, the different signatures of the spectroscopic bands that we can see are exactly the different situation that we can see of the collectivity of molecules that are placed in different parts of the semantic patterns, and not just the simple modes of the single molecules, bending, stretching, or rotation. I think that we are observing molecules that are placed in different places in the semantic pattern of the coherence domain, and they are expressing different dielectrical properties. This is just a work hypothesis, but I think that could be very consistent. So electrodynamics drives the chemical encounters. Them, in turn, changing the actors, modify the coherence domains, its frequencies. So they change the frequency of the field now present at each step. So we have a physical chemical based on the dialectics of bioelectromagnetism and biochemistry. And we could say, like Emilio told, the set of time-depending work frequencies of a given system constitutes its law of existence, its specificity. We could say its soul, its information, its psyche. Can you see there is nothing, there is no duality between soma and psyche. The psyche is the configuration of the soma, and the soma is configured as a psyche. So you can see that the living system is just a story of frequencies. Sorry, this slide is again here. And let me make a comment on this expression of the uncertainty principle of Heisenberg. This is the expression of it that emerges only in quantum field theory. What does it mean? It means that the complementarity principle exists also among two new variables, two observables, the phase and the number of the oscillators. What does it mean? It means that the more the phase is undefined, is dirty, let's say, is not precise, the more the number of quanta is defined. Let's reverse this sentence. It means that if I completely isolate a system and I close the system and I fix the number n, so I reduce the uncertainty on n to 0, this system will stop to be coherent because the phase will be completely undefined. In fact, which is the condition of the living system? Living systems are open systems. It means that a living system exists only as a continuous exchange process between of quanta with the environment, coming in and coming out continuously. If you stop this exchange, the coherence stops. The other important things of this principle are two. The first one is, as you can see, there is no the Planck constant on this side of the equation. Not just because it is written in natural unit, because if we wrote this in MKS system, we would just write 2 pi, 2 pi greco, 2 pi grecos. I don't know how to say in Portuguese. But so what does it mean? It means that this relationship, this complementarity holds at any scale, not only at the quantum level. This is something that tells us a very important aspect that is embedded in the previous comment that I made. That is this one. If it is true that the bigger the uncertainty over the number is, and the better the coherence is, because the better the phase is defined, it means that a coherent system will always tend to maximize the uncertainty on the number of oscillators. And the first way to do that is to increase the number of those oscillators that oscillate at the phase that is being held. So it means that each coherent system tries to oscillate in resonance, to get in resonance with other systems. This is the basis of the empathy. This is the basis of the perception, of the fact that in life, the system, the organism tends to set in phase their own oscillation. Imagine the phenomena of the swarming. like the sardines in the ocean, like the coral on the reef that make the things together, like the phase of the spawning. Imagine the starlings when they make the swarming in the sky. These are just a few examples, of course, but the most important aspect is that actually the web of life is not a naive expression, but is something that exists because all the coherent system, at least on some modes, oscillate in phase. So can you see how Darwin was still stuck to the classical physics and couldn't this idea of evolution couldn't work because life evolves as a whole. We look at the lion that prays the zebra, and we can see, look at, there is a fight, there is a collision, there is the violence, but actually the lions and the zebra are just like cells inside an organism that are oscillating in phase. And in an organism, you know better than me that sometimes some cells need to be apoptotized, need to be transformed, killed, substituted. Is the dynamics that maintain lives, is the turnover of cells, is the continuous processing. This is a completely reframe of the things. Like Vladimir told, what does it mean solid? Nothing is static. Anything is just a process that, independence on how fast is moving, you see it like something that is fixed. But let's think to the river. We always go to that place and we say, oh, look at this is the Amazon River. It's always, they say, it's always the Amazon rivers. It's just the name that hide the fact that that object is continuously different. Because you will never be able to enter the river, the same river twice. No? The river is a process. It's not a volume of water. So all these concepts now can be rooted in a consistent and rigorous physics of living matter. So just to synthesize, no? Some water molecules that are able, that necessarily are able because they are identical, but that are able to overcome a density threshold that creates a coherence. In the same way, when we have enough coherence domain able to oscillate in tune with other molecular partners to which to seize free energy and not thermal energy, we have supercoherence. And we have a fractal scale, a fractal hierarchy of coherences nested one into another. And this system could be said holographic because you cannot change nothing at this level, for instance, which is the level at which electrons oscillate in this system without changing all the other stuff. Because if you change the frequency of the domain, you will change the partners, you will change the chemical pathways, you will change all the evolution of the system at all the levels, and vice versa. If you change the chemical pathways or you stimulate the system in order to change certain frequencies, you also change which is the constitution of the semantic pattern of the coherence domain. This is the point that it is interesting in the homeopathy, because we have the possibility to select through the starting substance to select which is the final. Actually, it's not correct to speak of frequency. We should speak of huge pools, huge systems, huge symphonies of frequencies. Because another mistake that usually is made in conceiving information or whatever, I don't like this term, the concept of in homeopathy is the idea of staticness. But homeopathic remedies, like anything, are not something that has certain frequencies and in time they remain fixed. It is sufficient to, let me go directly, for instance, to the to a slide. It's sufficient to think what Tamar Innon showed by starting from the paper of Elia about the fact that, look at here, the remedy, homeopathic remedy that is showing certain values of polarizations that are not ordinary. You cannot find them in the liquid water, the ordinary liquid water. The polarization values oscillate and changes during the days. Look at here, 1,000 days, very long periods of oscillation. But the important point is that the dynamics that gives a, let's say, therapeutic function to a remedy is how it evolves, how it evolves in time, not a fixed pool of frequencies. So we should speak not of information, not a photograph, but a movie, dynamical configuration, because they are dissipative structure. And we cannot grasp, because another mistake is that maybe someone, this holds also for pH. If you measure pH in homeopathic in potentized systems, you see that the pH change in time. So it's not true that once that we can measure, okay, it's if not possible that if we measure a pH, automatically we can say, oh, being the pH of this value, this is something that has therapeutic functions, because it's not true. The therapeutic function can be only if we have the dynamics. So nothing has the recipe to say the recipe that this pH is of something that is therapeutic. It's not the point, because you could have also something else that is has the same pH but is not a potentized remedy. So to characterize the potentized remedy, we should make long-term measurements, okay? And we have to change all a lot of conception about condensed matter. Okay, now just to close my presentation, I skip all the parts about the emerging of life because we have no time. And I just tell you that if someone is interested in all these concepts, I have put them in this book that Leoni knows, and Evelyn as well. And I thank you for your patience, and sorry for my length, but it was a pity not to tell you at least all the stories, or at least a complete chapter of it.
Thank you, Paolo. It was wow. I think this year was better than last year. You put more things in a.
I try to skip the mathematical stuff, and I try to concentrate on to focus on.
Yeah.
Even if you know, I was very superficial in explaining the things. If we had time, we could explain the things much precisely, but
yeah, but I think maybe next year I will arrange the classes in 2 times, for example, to have more time too. But if you concentrate in the concept and this schemes and designs, it's good because it's superficial, but for us, it's very deep because it's our reality is different. We are We are still living in a sticks and balls world in the practice in our day by day. So it's everything is new, even if you show only
I would
small
have
things.
liked. I would have liked also to explain the things that Vladimir told about how is possible that we have also the phenomenon of the pH. No, how is it possible that the water molecule dissociates? It's not possible to dissociate the water molecule if the water molecule is isolated. You can dissociate the water molecule because it is partly coherent, and so you have that electrons can be given and lost easily, so you have the splitting and so many things, but okay, another time.
Okay, I don't know if someone would like to
May I
say
make
something.
a couple of
Vladimir, please.
comments? Thank you very much, Paolo. I would like to be very frank. If you give this part, second part of your talk, as the first part, it would be excellent. Because in fact, you are not in the company of physicists who you need to inform about all these formulas and so on. But the second part is really very important, and I think it is really very important. I would like to give one example, of biological example to what we were talking about. I think, well, everybody knows about such a phenomena when you take blood and you see erythrocytes, and these erythrocytes make stocks of piles.
Rouleau.
Of coins, yeah?
The rouleau, sì.
Rouleau.
Rouleaux, yes.
Yes, and for a long time, and not for a long time, until now, there is no good explanation in literature, I mean in the hematological literature, for this appearance of these rouleaux, because erythrocytes are negatively charged. So they cannot stick to each other if, because there is no one positively charged erythrocyte to negatively charged, then again positively, negatively, and so on. Still, they make all these rouleaux. And this is the first thing. Second, there are data which shows that if you mix erythrocytes, say, of birds and rats, then rat erythrocytes make their rouleaux, and bird erythrocytes make their rouleaux, and they do not. So they fractionate. So the explanations which are given in the literature, they are very fairy tales. Like there are very long molecules which bind the erythrocytes to each other, and so on and so things like this. Now, if to take what Paolo said, this explanation, then all the erythrocytes are oscillated, and they, as oscillators, according to these equations which he has shown, these oscillators of the same kind, they should find each other, and they do not stick to each other. As a matter of fact, that's very important. There is the distance between two erythrocytes. They are rouleaux, but there is water in between each of them, and the very intense rouleau formation, it's already, as you know, probably indication of some kind of pathology. And when there is no pathology, then erythrocytes become individuals. What Paolo said, it is a good foundation for understanding why one situation is kind of pathology, another situation is normal state, and so on, because they stick to each other because of, again, resonance, because of frequency. Only from this point of view. Now, basing on this principle, we can explain how tissues are formed. Well, why they have this, why hepatocytes find each other and they do not mix with fat cells. When they begin to mix with fat cells, something is wrong. From the current concept that molecules recognize each other by key and lock principle, there is no explanation of no morphology can be explained from key and lock principle. But from what Paolo said, there is the foundation. It's not already explanation, but at least that is the pathway along which we should go and understand morphology, which is normal morphology, which is changing morphology. And as a matter of fact, biology is morphology to the great extent. That is not chaotic protoplasm. That is really morphology. So morphology cannot be explained based on DNA principle. Many just agree completely that morphology is not written in DNA. There
Exactly.
are no genes of morphology. DNA writes only the instrument which
because they do not understand that DNA is something that also is readable through the mechanism of resonance. How can you explain? How can you explain that 1.5 meters of DNA, that is a huge distance, is readable in the exact point that is codifying for the protein that the cell needs to do? Just because when the cells has the need, the water frequency changes, and the resonance of between the ribosome and the DNA get in exactly that field, background field, and just this part of the DNA is read, and you have the codification for the protein. And all this Vladimir is saying is important because also all the team of morphogenesis is completely impossible to explain by conceiving the DNA like Francis Crick and Watson conceived it. DNA is something that is also physically working. And you can imagine exactly that also the colloids, also the tissue, all the cells bear a negative charge on the surface. How can cells be stuck together in a tissue? Because the tissue is the coherence domain of the cells, because they put in phase their oscillation and likes, and they set together. And there are many things that, but anyway, if you will be interested, I developed all this aspect because are very interesting thanks to the study made by Emilio and whatever. But it's very important to make this shift because medicine, like Vladimir told, is still stuck to the previous century, not understanding that the change are completely different.
So I wouldn't like the students to be disappointed that everything what they were studying in the lecture courses in biology, well, I wouldn't say wrong, but very insufficient for understanding life, very much insufficient. This knowledge is needed, but the conclusions are often, I wouldn't say fairy tales, but at least very slippery. The explanations which are given in the university course of the biological phenomena.
Part of the story, not the whole story, but part of the story. Yes, the other part you are discovering now.
So
thank you.
To understand this because this is the first step to proceed further. If we would like to find something new, we should understand that it exists. This new exists, and it really exists, this new. And not only polishing the current knowledge, they make it more and more precise, kilobytes, megabytes, terabytes of information.
Exactly. Thank you, Vladimir, for having been here waiting the end of the presentation. Thank you so much, because I know that in your place is late.
Yeah, the latest person is Vladimir. 6 hours and a half from here, so 5:30. Well, it's almost midnight. I have to sleep.
Yeah, so it is very late already. So I need tomorrow. I have a lecture at 9 o'clock in the morning,
Oh.
our time.
So I'd like to say thank you for all of you, to everyone since the beginning, to Vladimir, the hero, just now, and doing this, all these comments, and Paolo for all this. Again, it's lots of interesting, lots of new knowledges, and thank you for the students who are still here, brave students, and I hope you could get some, even if you could get some points, specific points from all these lectures, it works, because you are going to think about all these stuffs during the week, and the next week we can discuss a little bit more about the result of this whole journey. And then it's always opportunity to learn more and more, and it's not possible, it's not fair to give this discipline to you without put you in contact with these guys. That's and so I am very grateful to all of the professors who told things to us today, because
Thank
it's
you.
really, really important.
Thank you, Leoni.
So I need to
Thank
go
Okay.
now already.
Bye,
Yes,
Vladimir.
very
Thank
much.
you.
Oh.
Thank you. Thank you, everybody, for the
I was
patience.
And sleep well. And
Bye.
have a good end of the day to all. See you
Thank
next
you.
week. Bye bye.
Bye.
Thank you, Leoni. Thank you, everybody.